Okay. Hello. Hi. So it is our part 7, right? The part 7 lecture of our lecture series, the calculus for full calculus for full, right? Okay. So before proceeding, just recall of our previous lectures. I had just introduced to you the geometrical interpretation of the integrals, that means the sum of, right? So what was that actually? If I draw a coordinate system here, it is x, it is y, and if I draw a curve like y equals to x, okay, so the curve like y equals to x, so what will happen? Here it is a 0 comma 0, I mean origin here. It's a 1, it's a 2, it's a 3, a 4, it's a 5, a 6, it's a 7, and so many here. It's a 1, it's a 2, it's a 3, it's a 4, it's a 5, so many here. So y equals to x means the 0. If x is 0, then y is 0 here. If x is 1, then y is 1. If x is 2, then y is 2 here. If x is 3, then y will be 3. If x is 4, then y will be 4 here. And if I join these points with a line, it is obviously a straight line, right? Yeah, this. And the name of this straight line actually y equals to x. And actually I asked you to calculate the area in between x equals to 2 to x equals to 4, right? The area in between x equals to 2 to x equals to 4. X equals to 2, x equals to 4. Then what will happen? We just draw a line here, straight line here, and a straight line here. And of course, we will calculate the area in between this region, right? And it is the area, right? And just one way to do this thing. Actually, if you very smart guys, right? And just use a trapezium, right? I will name it just A, B, C here, the D here. The ABC is a trapezium, and obviously you already know the area of this trapezium, right? Another way to proceed this problem is actually if you calculate the whole area of this triangle. Whole area of this triangle is actually a right-handed triangle, right? So what is the area of this whole area? What is the area of this whole triangle? Half into base is the 4. Okay, and what is the height actually? If x is a 4, then according to a relation y equals to x, then obviously the height is actually a 4, right? Because it's the y. So half into 4 into 4, and it's the whole area, right? And if I subtract from it to this small area, I mean O, just name it O, OAD, right? OAD. So it is a half into 4 into 4, I mean it's OBC, right? It is the area of the triangle OBC. I mean the full area of this triangle, and if I just subtract from this area to this small area OAB, and in this area, so the left area left out, I just left out in this area, right? Just area of this trapezium. So the area of this trapezium, it is A, B, C, D. Actually, the big area OBC is minus OAB, right? The small area OAB. That means OBC means half into base into height. I mean half into 4 into 4. It's minus OAD means half into 2 into 2, right? Half into 2 into 2. Half into 2 into 2. That means half into 4 into 4 means 16 minus half into 4. That means half into 16 minus 4, that is 12, that means 6 units, right? So, the area of our consideration is the trapezium ABCD is actually 6 units, right? Half into 16 minus 4, or half into 4 into 4 minus half into 2 into 2, right? Or you can calculate it by our sum of, right? Sum of actually the integrals, right? So I just erase it, all of this thing. And I have to calculate this area, right? Okay. So, obviously, this is a big area, right? So you can cut it, this area, with very small pieces, right? So, this thing, okay, very small pieces. So, if this area, the whole area, if you call it A, then the very small area of this thing actually, if you cut these very small pieces, one of these areas we call DA, right? Okay. Then what will be the area actually? If it is x equals to 2, then y is actually, height of this thing, the 2, right? And the basis is a very little piece, it is a very large x, then it is a fraction of this thing, that dx, right? So this area actually goes to 2 into dx, right? It's a very small area, vast area, then 2 into dx. Okay. Then, if I introduce an area over here, we just name it, and this point actually just 2.5 here, right? It's a 2.5. Okay. So what is the y actually? If x is 2.5, then y obviously 2.5. But according to a relationship, the height of these areas actually 2.5, and the base is also dx. Okay. The areas of this thing actually 2.5 into dx, right? Okay. Then if you from 3 just introduce a very small area, that 3 here, yeah, it is. So if x equals to 3 here, then according to the relationship y equals to x, the height is actually y equals to 3, right? Y equals to 3 here, which is y equals to 3, and the base is obviously dx, and then the area of this very small chunk is equals to 3 dx, right? Now just consider another area. Just point it 3.5 here. This is 3.5. And just consider another area. So it is. So here the x is actually 3.5, right? This is 3.5. So according to the relation, the height will goes to obviously 3.5, and the base of course is dx, right? So this area, this smallest area will goes to 3.5 dx, right? Okay. And if you just calculate this piece, the infinite piece of area, so what will goes? Okay, just add this infinite piece of area, and just example here is that 2 dx, the first area 2 dx, and the middle area in between 2.2 and the 3 is the 2.5 dx, and in third is the 3 here, I introduce 3 dx here, and in between 3 and 4 the areas I will get 3.5 dx, right? And infinitely so many here, right? So actually the areas of these small things over and over, it is 2 dx plus infinitely many, and then 2.5 dx plus infinitely many, 3 dx plus infinitely many, 3.5 dx, and so on, right? Okay, right. It's a very simple. If you just cut these very big areas into very small pieces, the first of this thing actually 2 dx, and just I calculate the middle areas in between 2 and 3 is the 2.5 here, right? 2.5, and obviously according to the relation y equals to x, the height will goes to 2.5, the base is dx. So this area actually 2.5 dx, and there is 3, and according to the relation y is also 3, then this area is equals to 3 into dx, and then I introduce in between 3 and 4 there is 3.5 here, the area is goes to 3.5 dx. I just introduce here just 4 areas. Actually there is in between 4 areas there is infinite number of areas, right? Then I will dot it here, right? I just calculate just 4 areas, and in between the 4 areas there is just infinite number of areas, right? I just dot it here. Okay, just count it, dx, the common factor here, dx. So I left out 2.5 plus dot 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 dot, sorry, 2 plus dot 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 2.5 here plus dot 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 3 here plus dot 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 3.5 here plus dot 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 dx, right? Okay. Okay. And just see, is a 2.0 plus dot 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 means another just 2 something 2.1, 2.2, 2.3, and a very close to 2.001, 2.002, and just addition here, right? Okay, is a dx. But what does this means? 2.0, 2.5, 3, 3.5. It is just height, right? Height. It is the height. 2, 2.5 here, 3, 3.5 here. It is the height. And all of you know the height means actually, according to our relations, is the OI, right? And actually, it is the sum of y's. It is probably it is y1 plus dot 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 y2 plus dot 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 y3 plus dot 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 y4 plus dot 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 y5 dx, right? Okay, just a y. 2, 2.5, 3, 3.5 means just a y, right? It's a y. Height of these very small areas, right? The height. And the height means y actually. It's the y coordinate. The height means y. So it's all of these y's. 2.0 plus, dot 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 means 2.001 plus 2.00002. Such a way is 2.5, 2.5001, 2.5002, and this is 3 plus 3.001, and so many here. So it's not actually and y. Okay, and then y1 plus dot 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 plus y2 plus dot 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 y3. It means all of you know is actually summation, addition, right? And the addition means the integrals in sum of, just take it y, yeah, y1, y2, y, this is the y, this is the y dx, right? Okay, and the y means, because all of these y actually, y1, y2, y3, y4, y5 here, all of these y's, just y dx, and the addition means sum of, and there is a dx, right? It's the y dx. Okay. So y means what? X. Yeah. This is the x dx. This means actually x squared by 2 and 1 by 2 here, and x just introduced, I had introduced in previous lectures, is the x actually the large x minus the small x, right? Large x means 4 and the small x means 2. Just put it instead of x, just 4 square minus 2 square. This is a half into 16 minus 4, that means half into 12, that is 6 units, right? So actually it is a 6 unit. Okay? Okay, so it is our geometrical interpretation of integrals and geometrical interpretation of the sum of, right? Okay, so now I will introduce another rule of integrals, that means by parts rule. Just very simple actually, by parts rule. Okay, so recalling of our probably second part, second part of our lectures, I had introduced this product formula of dy over dx, and that was d dx of uv, and it will goes u dv dx plus v du dx, right? It is a product rule of dy over dx, right? Okay. So now, just from this thing, I will proceed of our by parts formula, right? Okay. Just cross multiply it with dx here. Just cross multiply it with dx here. You will get duv here. Is that u dv dx plus v du over dx into dx. Okay. And obviously it is just cut it here because the numerator here is the dx and the denominator is the dx, and here is also the denominator dx, numerator is dx. You can cut out. Okay. The left out equation duv equals to u dv plus v du, right? And then just apply this thing. So what you will get, it is the reverse relationship, the reverse operator d and this sum off. So obviously it will cut it. You will get here uv, and of course all of you know integral over dx means x, integral over dx squared means x squared, and the same thing here, integral over d of uv is a uv, right? And here is just u dv minus plus v du, right? So what is the u dv actually? Integrals over u dv actually, just take it here in the left. So uv minus v du. It is actually our bypass formula, right? It is actually our bypass formula. So probably in the actually who is belonging class 12 students, just puzzled. It is actually a bypass formula or not? It is actually bypass formula, right? Actually, it is bypass formula. Okay. So I just checked why it is bypass formula, and this is a well-known your bypass formula, tally, right? Just tally. So I just erase it. I just tell you it is your bypass formula, and probably you just puzzled. What it is, bypass formula or something like that. Actually, yes, it is your bypass formula. Just tell you, right? Okay. Just check why it works or not. Okay. So it is from here is a u dv equals to uv minus v du, right? Okay. So just here is the u dv. Just here, just divide this dx, and by correction terms, just multiply here dx, right? And same thing will happen. Just divide this dx and multiply with dx, right? Okay. And just let the dv dx equals to some anything, just f. dv dx equals to f, right? Okay. So dv dx equals to f. So dv equals to obviously f dx, just a cross multiply here. Okay. Okay. So if I introduce the sum of here, then it is the sum of a little bit of v, that means a v, so it is a f dx, right? Okay, the f dx. So v actually is a f dx. Just introduce these things. dv over dx equals to f, and v equals to f dx. Integral over f dx. Okay. So what you will get is the u dv over dx equals to f. This dx remains constant, equals to u. V means integral of sum over f dx minus minus the v means integral over f dx. Okay, it's a large integral. So v means integral over f dx. Sorry, and it's a du dx over dx, right? Yeah, probably it is your bypass formula, right? U into f dx, it is actually u integral over f dx minus integrals, large integrals. Okay, it is a large, sorry, it is a large integrals over f dx and du dx, here the dx, right? It is your bypass formula. And if I rearrange these things, suitable for you is u f dx equals to u f dx minus du dx integrals over f dx and it is the dx. Just I rearrange these things. So it is our just bypass formula of integrals. Right. Okay, so it is our probably the last topic. Hopefully the last topic. Okay. So the next class I will introduce you vectors, right? The vectors, and then I will introduce you graphs, the theory of graphs, right? So it is actually the end of our lectures, calculus for full series 1. Okay.